Welcome to U3L6 Simplifying Square Roots. So we're going to talk about square roots today. Hopefully this is something you've talked about before. This is technically pre-algebra and algebra 1 review, but we do need this skill in order to do lesson 7, which is distance formula, okay? So the square root of a number, and the square root symbol is this right here, is a smaller number which when multiplied by itself is going to give you the original number. So that's really the basis of what a square root is. So for example, square root of 16 is 4, and that's because 4 times 4 is 16. So if you look at the square root of 16 written as 4 times 4, you can see that you have the same number multiplied by itself, and so the answer to that is just a singular 4, no square root, and that's the answer, okay? So for a square root to simplify, there must be at least one pair of prime factors in the original number. There could be more than one pair, but there's got to be at least one pair of prime factors, because as you can see from this right here, the square root only has an answer when you have a pair of the same number in the radical multiplied together. Okay, and just so you know, I use radical and square root sort of interchangeably. Radical is a more general term. It encompasses more than just a square root. So when you hear me say radical, I'm talking about the square roots. Okay, so there's a special case here of square roots, which is called perfect squares. So a perfect square is a number or a number which has a square root that is a whole number. Okay, so for example, right, 16 is a perfect square, and that's because when you take the square root of it, you get a whole number 4. Okay, if you look, for example, the numbers from 1 to 100, there aren't very many perfect squares in there. Okay, but there are infinitely many if you just keep going, right? But you don't encounter the perfect squares quite as often as you encounter other numbers that are not perfect squares. Okay, so before you move on, I want you to go ahead, either on like the front on this part, okay, somewhere in the top area or something, or in your notebook, can you please write down some of these, or all of these, really, these perfect squares, so you can pause the video, but I took all the numbers from 1 to 15, and I multiplied them by themselves, and what I got was this list of squared numbers, and those are the perfect squares, because when you take the square root of them, you're going to get a nice whole number, and the answer that you're going to get when you take the square root is whatever's above it. So for example, if I took the square root, let's look here, of 81, I would get the square root of 9 times 9, and since it's a number multiplied by itself, I would get just a 9 there. Okay, so that's how that table works. So if you could pause the video and fill that table in. All right, and let's continue on. So here we go. So now we have find the square root of the following perfect squares. So I'm telling you these are perfect squares. Normally I wouldn't tell you. You would have to look and figure it out. But the square root of 49 is the same as the square root of 7 times 7, which means the answer is just a whole number, 7. Okay. Square root of 25 is the same as square root of 5 times 5, which means the answer is a whole number, 5. And the square root of 121 is the same as the square root of 11 times 11, which means the answer is a whole number, 11. Notice that our answers do not have a square root in them, right? When you take the square root of a number times itself, you get just a whole number with no radical, right? There's no radical on the outside. It's just a whole number. Perfect. Okay, so in the calculator, I do want to show you, and this is similar for most calculators, and you can also do this on a phone, you can do this on a computer, on any scientific calculator, but I want to show you how to type this in to check whether or not a number is a perfect square. So just give me a second. I'm trying to pull up the camera so I can show you guys. So if you look on your calculator, there's always going to be this square root as long as it's scientific, okay, the square root symbol. Here it's blue, so that means I click second, and then I click this x squared button, and then I get the square root. So if we type in one of the ones we just did, like 49, right, you're going to get 7. What if I try a different number? Let's try 50, okay, something close to 49. So if I do the square root of 50 instead, notice that I get a decimal answer. Whenever you get a decimal answer, that means that that radical, that square root, the answer is not a whole number. There is, whether it simplifies or not, okay, and I'll show you what simplifying looks like. Whether it simplifies or not, this means that there's always going to be a square root in your answer somewhere, okay? So whenever you get a decimal like that, there's a square root in your answer somewhere. All right, let's jump back over to finish our notes. So now what we're going to look at is how to simplify a square root. So here we go. So steps. So if it is, circle is a square root. Oh, not a square root, a perfect square, excuse me. Hold on, there we go. If it is a perfect square, okay. If it is a perfect square, already, like the ones, for examples 1, 2, and 3, then you're done. You're done, and its answer is the whole number that is its square root, right? You have a whole number answer, you're done. Now, if it's not a perfect square, that's when you have to see if it'll simplify. So you have to factor your term completely into primes. And then you're going to look for pairs of primes. Remember, pairs of numbers are what have a square root. For example, this pair of 11s has a square root of 11, okay? All right, so once you factor all of your, once you factor that number into primes, and you have all your primes, you have the prime factorization, then you're going to circle pairs of primes. So circle the pairs of primes. Only a pair of the same number has a square root. Cool. Once you circled those, one of each pair comes outside the square root, while factors with no pairs stay inside. Okay, so if it has a pair, it comes outside. If it has a pair, it has a square root answer. It comes outside. If it does not have a pair, then it stays inside because it doesn't have a square root answer. Okay, so think of it like this. If you have a date, if you have someone to go out with, you go out, right? You go out on a date. That's what happens when you're a pair. If you don't have someone to go on a date with, or you don't want to go on a date, you're single, then you stay inside, okay? You're not going out on a date, you're hanging out at home. That's sort of my way of explaining it, okay? All right, if you end up with multiple pairs of factors inside or outside, then you're just going to multiply them back together. So if you end up with like a double date or two single people hanging out at home, you just multiply them back together. So whenever you end up with multiple numbers, then you multiply them. Okay, so here we go. Let's take a look. So simplify each radical expression completely. Leave all answers as whole numbers or in simplest radical form. Okay, example 4. So square root of 14. You can check the list, make sure you can put it in the calculator. This is not a perfect square. So we're going to break it down. So 14 is equal to 7 times 2. Well, 7 and 2 are both prime. So the only way to write square root of 14 would be 2 times 7. But those are two distinct different primes. There is no pair of the same prime, which means I cannot simplify. Those are both going to go back in. That means the square root is the same as 2 times 7, which is 14. It went back to normal because it doesn't simplify. So this does not simplify. Doesn't mean that there's no answer. Like if you're doing a problem when we do distance formula, the answer is square root of 14. It just means it doesn't simplify. You can't make it any simpler, okay? It is as simple as it can be, okay? All right, example 5, let's take a look. This one will be a little more interesting. Square root of 20, not a perfect square. Okay, it's actually between 16 and 25. It's between two perfect squares. It's not a perfect square. Let's break it down. I'm going to go 2 times 10. 2 is prime, 10 is not. I'm going to go 2 times 5. 2 and 5 are both prime. I'm going to write square root of 20 in prime factorization in ascending order. So 2 times the other 2 times 5. Now, pair. I see a pair of 2s. I see 2 2s. Those have a square root. The square root answer is a singular whole number 2. This, however, 5, it's a prime that does not have a pair, so it does not have a square root. So that means it's going to be in our radical. So it's 2 times the square root of 5 is our answer there. All right, so you can pause the video and try this one. Square root of 28. See what you get. All right, so hopefully you got a prime factorization for this one of 2 times 2 times 7. You got your pair of 2s. You took that out of the radical. You left your 7 in the radical. All right, let's look at another one. So square root of 72, here we go. Again, not a perfect square. You can check in the calculator. You get a decimal, so this is between 64 and 81. So it's somewhere between 8 and 9. It's going to be 8 point something when you do it on the calculator. So we'll break it down instead. So 72, there's a lot of ways to start this. I'm going to start with 9 times 8. 9 is 3 times 3, both prime. 8 is 4 times 2. 2 is prime, 4 is not. Keep going. 4 is 2 times 2. Keep in mind that the prime factorization is primes only, right? So you need to ignore all these composite numbers that you broke down. Okay, those don't matter right now. 72 as well. None of those matter right now. We just want our prime factorization. Okay, so square root of 72 is the same as the square root of 3 2s and 2 3s. So 2 times 2 times 2 times 3 times 3. Now, we need primes. We need, not primes, we need pairs of primes. Pairs, not triplets, pairs. So twins, not triplets. So we're looking at 2 2s. The extra 2 does not count as part of the pair because it is an extra. It's a third one, okay? This is a leftover. But these 2 pairs of 3s as well count. So we actually have 2 pairs of numbers that have a square root. So we can take a 2 out of our radical and a 3 out of our radical, and we multiply them back together. With the 2, we leave it in the radical because it doesn't have a square root. So this leftover one stays in. 2 times 3 is 6, so we have 6 square root 2, and that is our final answer there. All right, so for this last one, I'm going to give you, let me see what I want to give you. I'm going to give you 2,100, because if you can do this one, you got it. Okay, so you can double check in the calculator first that it's not a perfect square, okay? And then you can go ahead and break it down and go from there. So pause the video and try that. All right, so let's go ahead and do it. So 2,100, I know because it ends in 2 zeros, I can divide by 100, and that's going to be 21 times 100. Those are not prime. I'll go on the 100 side, that's 10 times 10. 10 is 5 times 2, both prime. This 10 is also 5 times 2, both prime. Don't forget to circle your primes, otherwise sometimes you might forget. You'll miss them, right, when you go back and look. All right, 21 is 3 times 7, and those are both prime. So we're looking at, I'm going to write it down here because I don't really have room, the square root of 2 2s, a 3, 2 5s, oops, and accidentally messed that up, and then a 7. So let me double check. I have 2 2s. I have 2 5s, my 3, my 7. Okay. Now we're looking for pairs. So we have a pair of 2s and a pair of 5s. We have a 3 and 7 that do not have a pair. So the 2 times 2 has a square root of 2. 5 times 5 has a square root of 5. 3 times 7 do not have a square root, so they go inside. So remember, anytime you have multiple numbers, right, outside or inside the radical, you multiply them back together. So 2 times 5 is 10, square root of 3 times 7, which is 21, and we're done. All right, thanks for watching, everyone. Have a great day.